John Hayes here, K7VE from Northwest Digital Radio. Today I'd like to introduce you to the JAWS Manager. JAWS Manager is a web application for setting the levels on your JAWS hat. Okay, a little bit of orientation on a couple of things. The software that does the JAWS Manager is located in this directory, /users/local/var/JAWS Manager, and under that a subdirectory called Web App. There's a couple of things that you probably should be aware of. When you first install the image, there are a series of scripts that are under or the home directory for Pi. If you go into N7NIX, you'll see that there is a bin directory. You go to the bin directory and you'll see that there's some setalsa shell scripts. To prime the pump, choose one of these just to get started. I just say start with setalsa. Notice the dash in front there, and let's use the FT817, which is a common platform, if I could type correctly, and that will actually do a sudo before those. That will prime the pump, so to speak, and then you'll make adjustments from there using JAWS Manager. Also, you will want to be able to turn on and off the JAWS Manager. As I explained in the video, you don't want it to the open internet, and it's probably best to have it turned off when you're not actually using it. To do that is fairly simple. You can turn it off by doing sudo system control stop JAWS Manager, and that turns it off. To restart it, you just do a start JAWS Manager. If you want to make it so it does not start up whenever you start up your machine, you would do the same command, but would put disable. And of course, to bring it back, you would do enable. So those are just some of the startup things that you want to do. JAWS Manager will make it possible for you to make changes to the levels in the JAWS board once you've done this. Another file that you may want to be aware of is in etc defaults. Default, not defaults. If you look in there, there's a file called JAWS Manager. Use your favorite editor. There are several available. I happen to use VI. You can change the port. We default to 8080, but here's a potential other one. You can make it so that it only operates on the local host, or 127.0.0.1, by uncommenting that. I'll undo that. Right now I have it set default to listen on all ports, both IPv6 and IPv4. So be aware of that, and you can make changes there if you need to. There is a service file under libsystemd system. If you're familiar with service files and want to make changes, that's where it's located. Just be advised any updates will overwrite that. So that's your basic terminal instruction before we actually get into JAWS Manager. So next we'll do a demo. Okay, once you've loaded the image onto your Raspberry Pi, from the beta image located at images.northwestdigitalradio.com, it will come up and you will be able to open a browser and point it either at the local area network IP address for your Raspberry Pi or to localhost and port 8080, so :8080, and you will get the DRAWS Manager. The DRAWS Manager is in continued development, so you will want to update it. Let's take a quick look at how you update the DRAWS Manager. Alright, so open a terminal window to your Raspberry Pi and log in, and once you're logged in, you will need to go to directory/user/local/var/DRAWS Manager. And we're going to pull down the latest version of DRAWS Manager by typing git pull. If you get that, it's because you need to be root to do that, so it's a sudo git pull. And now it's updated all of the current pages for the DRAWS Manager. Let's take a look at the new interface. Once we've done the git pull, you will see that a refresh of the DRAWS Manager now has some new controls added to the interface. Let's look at what the various controls do. On the left is a menu of various actions that can be taken by the DRAWS Manager. We can restart the GPS daemon, we can stop it, we can sync the system's clock to that GPS. Clicking these has no feedback, but it will do the update in the background. So the ones that we'll most be concerned with as a user are the ones that are shown by default, which we have here. There's a set of controls for the left Mini-DIN6, which when you're looking at the board on the side where the mini-DINs are located, there's a left and a right. So the left mini-DIN controls are on the left side of the interface. The right mini-DIN is on the right side. Pretty easy to keep straight in your mind. So there's several things that need to be set for proper operation. One is which pin is the signal from the receiver going to come in on. On a typical 6-pin interface to amateur radio using the packet standard, there are 2 pins. There's the audio frequency pin, which is pin 5, which you can see in the diagram here, or pin 4, which is the discriminator. Pin 5 is typically used for 1200 baud packet, some of the HF digital modes, and so on. The discriminator is used for more sophisticated modulation, such as 9600 baud packet or GMSK for D-Star and so on. Receiver gain is a little more forgiving than transmitter gain. You pick a level until you're getting decodes, and that should work just fine, and then you move forward from there. Next, we need to set the transmitter. This is much more critical. Depending on the expected input voltage to your transmitter on the audio level, these levels need to be set. We always start with the analog gain. Typically it will be at something like -6. Then we fine adjust that with the digital gain, and the combined values here create the value that will be used to feed the transmitter. We have some pre-selected radios. Right now these are still being finalized. You can use them as a starting point. They will get some more refined ones. We'll build the list over time. If we select these, you will note that it does update the values here. So if you're changing radios, you can select the proper input for it. You'll also note there's a bit of a delay between when you make the selection and when they appear here. That's because in the background, so that we're not loading the CPU too much, we're only sampling about once a second to update. So always wait at least one Mississippi before you've decided the value's taken it or not. We've also added some sliders to change the values, so you can use those as a rough approximation and then zero in from that point forward. Those are the basic setups. Once you have them, then you'll select Save Audio Settings on the left. Though that will persist the settings that you set into your Raspberry Pi, so that when you reboot, those values are set. If you don't have a radio connected to one side or the other, set it to off, and that will actually turn down that side of the sound chip so that you won't get crosstalk or other things brought in. In addition to the settings, we have some telemetry happening. If you look down here at the bottom of the window, you'll see that we're getting some feedback. It tells us what the product is, the DRAWS station, what adapter inside the Raspberry Pi is reading values. We see some differentials, including the voltage for the power supply. Right now we're at 14.09, feeding the hat, which in turn feeds the Pi. If you had some personal readings coming in off of the accessory port, those would be reported here as well. It does tell you what version of Raspberry Pi you have, and gives you CPU utilization, temperature, and load averages, and so on. So you have a little bit of telemetry here. In general, you won't leave this application running all the time, but if you need to go sample that, this is a good place to do it. The other thing is there are a couple of hidden things on the page. If you hover over the DRAWS statement there, you'll see the vendor is Northwest Digital Radio, the product ID and the version number. If you're reporting issues back to Northwest Digital Radio or other users, that's valuable information that you may want to pass along. Also, if you hover over the image of the Mini DIN 6, it shows that this is the socket view. So looking into the socket, that's the pin pattern. There are some advanced controls that are typically not used, but if you want to see them, they're here. If you need to change them, you can change them here. You toggle that off. If you're starting with a radio that isn't in the pull-down list, or you don't know the values that should go in, there is a transmit calculator. The calculator is looking for the peak-to-peak input voltage that should be going into the transmitter. Once you put that value in millivolts, here we've got 1000 millivolts, but let's change that to say it wants a half a volt peak to peak. We press enter. It gives us the values to put into the analog gain and digital gain for the transmitter. So in this case, it would be -3 dB or -9 dB for I'm sorry, it would be -6 for the analog gain, -3 dB for the digital gain, which remember is kind of like your trimmer, giving a total gain of a -9 dB. I do put in parentheses what the true value should be out to 2 decimal points. It's not quite that fine a resolution, but it gives you an idea of where you are. And it does do round up, round down to give you the closest possible value. That's the basics of running the DRAWS Manager. When you're done, you just can hop out of it. As I say, you get to it either if you're on the Raspberry Pi with the browser, or through VNC using localhost port 8080, or you can do it over the LAN with port 8080. Just a word of caution, the operation of this tool runs as a privileged user, so you do not want to expose it to the open internet. So please make sure your firewall is blocking access to it if you are doing any port forwarding. Also, you may wish to shut it down when not in use. I will demonstrate how to do that in a terminal window. But have fun with it. As I say, it is under development. There will be things coming like the ability to save your own settings into the drop-down menu and a few other options like that. So thank you very much. This is K7VE, John.